Welcome. This session, we are going to discuss how to solve simultaneous equations, simultaneous differential equations by method of Laplace transforms. So let's see a specific example. So we have to solve the system of these two differential equations, subject to the condition that the value of x at 0 when time is 0 and y at time is 0 is 0. So this is how we get the result. So note that solution. The first thing, let a Laplace transform of x given by capital X of S and Laplace transform of y be given by capital Y of S. So taking, I call this one equation 1, call this one equation 2, Laplace transforms on both sides of 1 and 2 we get Laplace transform of x prime plus Laplace transform of x plus a half Laplace transform of y prime is given by Laplace transform of 1. And second one will be Laplace transform of, actually I have Laplace transform of x prime plus Laplace transform of y prime plus Laplace transform of y equals to Laplace transform of 0. Now remember that Laplace transform of x prime by definition will be given by s capital X of s minus value of x at 0. So it should just be s capital X of s, because this one is given as 0 in the equation, and Laplace transform of y prime is given by s capital Y of s minus y at 0, and this just be s capital Y of s, since this and this are 0 from the equation. So if I call this one 3, I call this one 4, and also note that Laplace transform of 0 is 0, and Laplace transform of 1 is given by 1 over s. So if we factor all this, if I call all these ones 5, then using 5 capital X of s for L, and then capital Y of s for Laplace transform of y, 3 and 4 becomes so we are going to replace where this derivative of a Laplace transform with derivative of x by x, capital X of s, derivative of y Laplace transform to be s capital Y of s. So 3 will be s capital X of s minus, actually I've already taken care of minus 0, so I'll just plus capital X of s, and then plus I have into s capital Y of s is equals to 1 over s, i.e. we have s capital and then plus capital X of s plus I have s capital Y of s equals to 1 over s. And then this is from equation 3. And then equation 4 will become s capital X of s divided by 2 plus s capital Y of s, and then plus capital Y of s equals to 0. So I'm simply now rewriting these two equations. I'm rewriting this equation 3 and equation 4. So I'll have, so this is from equation 3, and this from equation 4. So if I call this one now equation 5, equation 6, and I call this one equation 7, then 6, from 6, we have s plus 1 times capital X of s, and then plus I have s capital Y of s equals to 1 over s, and then from 7, so s over 2 capital X of s plus s plus 1 multiplied by capital S Y of s equals to 0. So you can call this one equation 8. You can call this one equation 9. So then now our intent is now to solve for this capital X and capital Y. So from equation 9, we have capital, making this one the subject, capital X will be negative. So multiplying through by 2, so I'll have 2 into s plus 1, capital Y of s, and then I divide by s. So let me call this one 10. So I replace 10 in 8, where there's capital X of s. So replacing 10 in 8, we have, so s plus 1 times the value of x, which is s plus 1. So I'll have s plus 1 I multiply by -2 into s plus 1 over s times capital Y of s. And then the next part will be I have sy and then the right-hand side of the 8 is 1 over s. So remember this, this multiplication. So at this point, I'll have -2 into, actually this and this one, they're multiplying, so it will be s squared plus 2s, then plus 1. And then divided by s. This other one will be plus s over 2, so I can say s over 2. And then capital Y of s should give me 1 over s. So this one I'll get LCM here is 2s. 2 into 2s is s, so s squared minus s into 2s is 2, so -2 times. So this will be -4 into s squared plus 2s plus 1. And then you multiply by capital Y of s equals to 1 over s. So that I'll get s squared minus 4 s squared minus, so 4 times 2 is 8, 8s minus 4 divided by 2s. This is capital Y of s equals to 1 over s. Now this will give me -3 s squared minus 8 s minus 4 divided by 2s. I multiply by capital Y of s. This should give me 1 over s. So making y the subject, I'll multiply through by 2s over minus 3s squared minus 8s minus 4. So 2s over minus 3s squared minus 8s minus 4. So this and this cancels out. So this and this cancels out. And then these two and these two cancels out. So y of s will be 2. Actually, I can factor, say -2 and then 3s squared plus 8s and then minus a plus 4. So that product of this quadratic is 12, sum is 8. So numbers 6, 2. So I'll have 3s squared plus 2s plus 6s plus 4. So common here is s into 3s plus 2 plus common here is 2, 3s plus 2. So when I factor, I get s plus 2, 3s plus 2. So therefore, y of s is given by minus 2 divided by s plus 2, and then 3s plus 2. Now you decompose into partial fractions. So decomposing into partial fractions will have minus 2 over s plus 2, and then 3s plus 2 equals to a over s plus 2 plus b over 3s plus 2, which implies that minus 2 is equals to a into 3s plus 2 plus b into s plus 2. And so this is the same thing as if you set s to be minus 2, then we'll have minus 2 equals to minus 2 times 3 is minus 6 plus 2 minus 4, so it'll be minus 4a. So it means a is a half. And then if I set s to be, so for me to get this from 0, so I need to have minus 3 over 2, minus 2 over 3. So I'll get minus 2 equals to, so minus 2 over 3 plus 2. I'll get 2 minus 2 over 3 4 over 3 b, so which implies b multiplied by 3 over 4, b over 4, so it's negative 3 over 2. So minus 2s plus 2, which is y, into 3s plus 2, the same as a, we got the answer to be a half, s plus 2, and then minus, so we'll have 3 over 2 over 3s plus 2. Now we can factor this one as a half into 1 over s plus 2, and then minus 3 into 3s plus 2. So that taking inverse Laplace transform will have inverse Laplace transform of y is a half inverse Laplace transform of 1 over s plus 2 minus, actually this would be, I can divide this one as, okay, let me just write a half inverse Laplace transform of 3 over 3s plus 2. And so the first one is a standard value whose answer would be a half e raised power minus 2t if used tables of Laplace transforms. But this one, we can write it as minus a half, and then inverse Laplace transform of. Now we make this one, we divide every term here by 3. So we write this one, divide by 3 over 3 over 3. So that will have 1 over s plus 2 over 3. By doing that one, then that will give us a half e raised power minus 2t minus a half e raised power now minus 2 over 3t. So this is the value of y of t. Now, x of t, of course, remember from here, we say that x of t is given by this. So if you know the value of, so at this point here, so similarly, you can make x the subject. So make y the subject in this case, and then solve for x. Now also, we make y of s the subject in, so remember this where we picked it from, this in equation 9, from this equation 9 here, at this point. So when you make y the subject, you'll have now y of s will be given by s minus s over 2 into s plus 1 capital X of s. And so you use this value here in 8, and so we'll have s plus 1 capital X, and then plus a half s, where this y you put times negative s over 2, and then into s plus 1 times capital X of s. This will give us 1 over s. So this is the same as s plus 1 and grab this one now. So then now we write this one as s plus 1, and then this will have a negative sign, so this will be s squared over 2 by 2 is 4, s plus 1, and then this one we have capital X of s, which should give us 1 over s. Now you can put over 1 here, and so we'll have 4 into s plus 1. This goes into this LCM, so it'll be s plus 1, 4s plus 1 times s plus 1 minus s squared, and then x of s equals to 1 over s. And let's work this part. So this will be 4 into s squared plus 2s plus 1, and then minus s squared over 4 into s plus 1. So I'm just trying to simplify this part. So this will be 4s squared plus 8s plus 4 minus s squared divided by 4 into s plus 1. Remember, this will be now multiplied by capital X of s, should give us 1 over s. So which tells us that 4s squared minus s squared is 3. So this is the same as 3s squared plus 8s plus 4 over 4 into s plus 1. We multiply by capital X of s. This will give us 1 over s. Now let's see, this one product is 3 times 4 is 12. Sum is 8. Numbers will be 2 and 6. So when you rewrite this numerator, you'll get 3s squared plus 2s plus 6s plus 4. So this will be s into 3s plus 2 plus 2 into 3s plus 2 . So we'll have 3s, so 3s plus 2 times s plus 2 divided by 4 into s plus 1. And then all this multiplied by capital X of s should give us 1 over s. Now we multiply both sides by the reciprocal. So that you will have X of s will be 4 into s plus 1 over s into 3s plus 2, and then into s plus 2. So you decompose into partial fractions. So decomposing this one into partial fractions, will get a over s plus b over 3s plus 2. And then, so we do the same thing as writing a over s plus b over 3s plus 2 plus c over s plus 2. Now, when you solve this, solving, you will get A to be 1, B to be -1, and C to be -1. You can confirm that. So then, which means that capital X of S will be 1 over S minus 1 over 3S actually when you solve, so this B will be -2. This also be -2. So B will be -3. B will be a half, not B will be -3 over 2. So in solving, B will give you -3 over 2. This other one will be -1/2. So we'll have negative, rearranging will give X of S will be 1 over S and then minus. So this can be written as 1 over 2 into S plus 3 over 2, 2 over 3, and then minus 1 over 2 into S plus 2. And so taking the Laplace transform, inverse Laplace transform, so inverse Laplace transform of capital X of S, which will give X of t, you'll get the answer to be 1 minus a half e raised power minus 2 over 3 t, and then minus a half e raised power minus 2 t. So this is what you get. Thank you.